Close your eyes for just 1 second. Now imagine standing on a grain of sand in the middle of the Sahara Desert. That single grain under your feet, that tiny, almost invisible speck, that is our entire solar system compared to the galaxy we live in. Tonight, we are not just talking about stars. We are not just talking about planets or moons or black holes. Tonight, we are going on a journey so vast, so enormous, so absolutely mind-shattering that by the time we are done, you will never look at the night sky the same way again. Every single dot of light you have ever seen above you is part of a structure so large that even light, the fastest thing in the entire universe, takes 100,000 years just to cross from one side to the other. You think you know the Milky Way? You think you understand where we live? Think again, because what you are about to hear will make your jaw hit the floor, your brain stutter, and your entire sense of reality crack wide open. Buckle up, because this is going to change everything you thought you knew about the place we call home. And trust me, once you hear the numbers, once you see the scale, once you truly understand how impossibly massive our galaxy really is, you will realize that humanity has barely scratched the surface of the universe. So stay with me, stay locked in, because every single detail from this point forward is going to blow your mind into a million tiny cosmic pieces. When we talk about the size of the Milky Way, most people nod their heads and say, yeah, it is big, but nobody truly understands what big means in this context, because the numbers are so outrageous that the human brain was never designed to process them. The Milky Way stretches approximately 100,000 to 180,000 light-years across, and recent studies have pushed that estimate even further, suggesting it could be close to 200,000 light-years in diameter. Now let that sit for a moment. One single light-year is about 5.88 trillion miles, so when we say 100,000 light-years, we are talking about a distance so enormous that if you wrote the number out in miles, it would fill pages and pages of paper with nothing but zeros. To put it into some kind of perspective, if you could somehow board a spacecraft traveling at the speed of light, which is 186,000 miles per second, it would still take you 100,000 years just to travel from one edge of the Milky Way to the other. That means if you started your journey when early humans were first painting on cave walls, you would not even be halfway across by now. The fastest spacecraft humanity has ever built is the Parker Solar Probe, which travels at roughly 430 miles per hour, and even at that blistering speed, it would take over 26 billion years to cross the galaxy, which is almost double the current age of the entire universe. We live inside this structure every single day of our lives. We orbit within it. We are made from its dust and gas. And yet the sheer scale of it is so far beyond anything we encounter in daily life that it might as well be a fantasy number from a science fiction novel, except it is absolutely real and confirmed by decades of astronomical observation and measurement. The Milky Way is not just a wide, empty stretch of dark space. It is absolutely packed with stars. And when scientists say packed, they mean somewhere between 100 billion and 400 billion stars are swirling around inside this one single galaxy. That range alone is staggering, because even at the lower estimate of 100 billion, if you tried to count every single star at a rate of 1 per second without stopping to eat or sleep or breathe, it would take you over 3,170 years to finish counting. And that is just the conservative number. Many modern estimates lean toward the higher end, closer to 200 or even 400 billion stars, each one a burning ball of nuclear fusion, many of them far larger and more powerful than our own sun. Some of these stars are red dwarfs so small and dim that they are nearly invisible even to our most powerful telescopes, while others are blue supergiants, hundreds of times the mass of the sun, burning so furiously that they will explode as supernovae within just a few million years. And here's what really bends the mind. Around most of those stars there are planets, moons, asteroid belts, and entire solar systems of their own. Current estimates suggest there could be more planets in the Milky Way than there are stars, which means we could be looking at over 1 trillion planets inside our galaxy alone. Each of those planets has its own story, its own composition, its own potential for chemistry, and maybe even life. And we have barely explored a handful of them. Our sun, the star that lights our world and sustains every living thing on Earth, is just one ordinary middle-aged yellow dwarf star among hundreds of billions, sitting quietly in a suburban arm of the galaxy, doing absolutely nothing special by cosmic standards, yet meaning everything to us. Most people picture the Milky Way as a flat, spinning disk, and while that image is partially correct, the full truth is far more complex and fascinating. The Milky Way is a barred spiral galaxy, meaning it has a central bar-shaped structure made of stars with spiral arms winding outward from the ends of that bar like a cosmic pinwheel. The disk of the galaxy, where most of the stars, gas, and dust reside, is about 1,000 to 2,000 light-years thick, which sounds thin compared to the diameter, but remember that even 1,000 light years is a distance so vast that light itself needs 10 centuries to cross it. Beyond the visible disk, there is a much larger structure called the galactic halo, a roughly spherical region that extends far above and below the disk and contains old stars, globular clusters, and massive amounts of mysterious dark matter. This halo could extend 300,000 light years or more from the center, making the total volume of the Milky Way's influence far larger than just the flat disk we typically imagine. At the very center of the galaxy sits a supermassive black hole called Sagittarius A star, which has a mass equivalent to about 4 million suns compressed into a space smaller than our solar system. Everything in the galaxy, every star, every planet, every grain of dust, orbits around this central gravitational monster in an enormous, slow cosmic dance that takes our solar system roughly 225 to 250 million years to complete just one single orbit. That means in the entire history of Earth, our planet has only made it around the galaxy about 20 times, and each of those trips has seen mass extinctions, continents reshaping, and entire species rising and falling, while the galaxy just kept spinning silently and endlessly. Here is something that should genuinely humble every single person alive. Our entire solar system, the Sun, Earth, Mars, Jupiter, Saturn, all 8 planets, all the moons, all the asteroids, and the entire Kuiper Belt, occupies a position in the Milky Way that is essentially the cosmic equivalent of a tiny house in the far suburbs of an unimaginably large city. We are located in what is called the Orion Arm, sometimes called the Orion Spur, which is a minor spiral arm sitting between two much larger arms called the Sagittarius Arm and the Perseus Arm. We are roughly 26,000 light years from the galactic center, which puts us a little more than halfway out from the middle toward the edge. This location is so unremarkable, so completely average, that if an alien civilization on the other side of the galaxy were scanning for interesting places to visit, they would almost certainly pass right over us without a second glance. Our sun is not particularly bright, not particularly large, not particularly young or old, and our position in the galaxy is the definition of ordinary. And yet this seemingly boring average location might be exactly why life was able to develop here in the first place. Scientists refer to our region as being within the galactic habitable zone, a band within the galaxy that is far enough from the chaotic radiation-heavy center to avoid constant sterilization by gamma-ray bursts and supernovae, but close enough to have the heavier elements necessary for rocky planet formation and complex chemistry. If we were closer to the center, we would likely be bombarded by deadly radiation, and if we were further out, there might not have been enough heavy elements to form a planet like Earth in the first place, so our boring, unremarkable position might actually be the reason you are here listening to these words right now. The Milky Way is not a peaceful, quiet island floating serenely through the void of space. It is a gravitational predator, actively consuming smaller galaxies and adding their stars, gas, and dark matter to its own mass. Right now, at this very moment, our galaxy is in the process of devouring several smaller satellite galaxies, the most notable being the Sagittarius dwarf elliptical galaxy, which has been slowly torn apart and stretched into long streams of stars that wrap around the Milky Way like ribbons being pulled into a drain. This process, called galactic cannibalism, has been happening for billions of years, and the evidence is written across the sky in the form of stellar streams, unusual star orbits, and chemical signatures that reveal certain stars in the Milky Way were not born here, but were stolen from other galaxies that no longer exist as independent structures. The Large and Small Magellanic Clouds, two irregular galaxies visible from the southern hemisphere, are also gravitationally bound to the Milky Way and will eventually be absorbed into our galaxy over the coming billions of years, adding their billions of stars to our own collection. But the most dramatic event is still ahead. In approximately 4 to 5 billion years, the Milky Way and the Andromeda Galaxy, our nearest large galactic neighbor located about 2.5 million light-years away, will collide and merge in a spectacular gravitational dance that will completely reshape both galaxies into a single massive elliptical galaxy that scientists have already nicknamed Milkomeda or Milkdromeda. This collision will not actually result in many direct star-on-star impacts because the distances between individual stars are so enormous, but the gravitational chaos will fling solar systems into entirely new orbits, trigger massive waves of new star formation, and fundamentally alter the structure of everything we currently call home. Perhaps the most mind-bending way to truly appreciate the size of the Milky Way is to consider it from the perspective of light, the fastest thing in the known universe. Light travels at approximately 186,282 miles per second, which means in just 1 second, a beam of light could circle the Earth more than 7 times. In 1 minute, light travels about 11.2 million miles. In 1 hour, about 670 million miles, and in 1 year, it covers a staggering 5.88 trillion miles, earning that distance the name 1 light year. Now consider this. The Milky Way is at minimum 100,000 light years across, which means a photon of light leaving from one edge of the galaxy traveling at this absolutely incomprehensible speed would need 100,000 years to reach the other side. To put that in human terms, when that photon started its journey across the galaxy, Neanderthals were still walking the Earth, modern humans had not yet left Africa, there were no civilizations, no languages, no agriculture, no cities, no history as we know it, and that photon would still be traveling right now. It would not arrive at the other edge for another roughly 75,000 years from today. And if you factor in the galactic halo and the extended structures that surround the disk, the true extent of the Milky Way's gravitational influence might reach 600,000 light-years or more, making the actual journey even longer. We talk about the speed of light as if it is the ultimate benchmark of fast, and in our daily human lives it absolutely is, but on the scale of our own galaxy, even light is humbled. Even light is reduced to a slow crawl across an ocean of space so vast that it challenges the very limits of what the human mind can picture or comprehend. Tonight we have traveled from one edge of the Milky Way to the other. We have counted its hundreds of billions of stars. We have measured its impossible diameter. We have stared into the supermassive black hole at its heart, and we have witnessed it devouring entire galaxies whole. We have learned that our solar system is a tiny forgotten dot in a quiet suburb of a galaxy so large that even light takes 100,000 years to cross it. We have seen that the Milky Way is not static, not peaceful, and not finished growing. It is a living, evolving, consuming giant, and we are riding inside it on a small blue planet orbiting an ordinary star, completely unaware most of the time of the breathtaking enormity of our own cosmic home. The numbers we discuss tonight are not fiction, they are not exaggeration, they are the measured, studied, peer-reviewed reality of the universe we inhabit, and they should fill every one of us with a profound sense of wonder and humility. We are small beyond description, and yet we are the part of this galaxy that woke up, looked around, and asked, how big is this place? That question, that curiosity, that refusal to stop exploring is what makes humanity extraordinary, even in the face of a universe that dwarfs us in every measurable way. So the next time you step outside on a clear night and you see that faint glowing band stretching across the sky, remember what you learned tonight. Remember the scale, remember the numbers, and let it remind you that there is always something bigger, something deeper, something more extraordinary waiting to be discovered. Good luck to every single one of you as you carry this cosmic perspective into your daily lives. Let the enormity of the Milky Way inspire you to dream bigger, reach further, and never stop being amazed by the universe that created you. Thank you from the bottom of my heart for giving me your time, your attention, and your curiosity tonight. It has been an absolute honor to share this journey across the galaxy with you. Stay curious, stay humble, and never stop looking up.